6238. One of the best visual indications of a thermal is A. Smooth cumulus cloud with a concave base. B. Broken to overcast sky with cumulus clouds. C. Fragmented cumulus cloud with a concave base. The correct answer is A. When it comes to identifying thermals visually, a smooth cumulus cloud with a concave base is considered one of the best indications. Thermals are columns of rising air, and as they ascend, they can sometimes create cumulus clouds. Cumulus clouds form due to the upward movement of warm, moist air that cools and condenses as it reaches higher altitudes. The correct answer states that a smooth cumulus cloud with a concave base is a strong visual indication of a thermal. Let's break down the characteristics of this cloud formation. Smooth cumulus cloud. A cumulus cloud appears as a puffy, cotton-like cloud with a distinct rounded shape. However, in the case of a thermal, the cumulus cloud associated with it tends to be smooth. This means that the cloud formation maintains a relatively uniform and well-defined shape, without significant irregularities or sharp edges. Concave base. The base of the cumulus cloud associated with a thermal display a concave shape. A concave base refers to a curved, inwardly sloping appearance, similar to the shape of a bowl or an upside-down dome. This concavity at the base indicates that the thermal is actively lifting and creating the cloud formation. The presence of a smooth cumulus cloud with a concave base suggests the presence of a strong thermal. As the thermal rises, it carries moisture and condenses it into a cloud. The smooth and concave characteristics of the cloud indicate a stable and organized thermal column, which is more likely to provide significant lift for gliders, birds, or other objects relying on thermal updrafts. Pilots and glider enthusiasts often keep an eye out for such cloud formations as visual cues to locate areas of thermals. By observing the presence of a smooth cumulus cloud with a concave base, they can identify potential sources of lift, helping them to navigate and optimize their flight paths. 6240, which is true regarding the development of convective circulation. A. Cool air must sink to force the warm air upward. B. Warm air is less dense and rises on its own accord. C. Cool air surrounding convective circulation sinks at a greater rate than the warmer air rises within the thermal, thus forcing the warmer air upward. The correct answer is A. Temperature and density. Warmer air is generally less dense than cooler air. When air is heated, its molecules become more energetic and spread apart, resulting in a decrease in density. Conversely, cooler air has more closely packed molecules and is denser. Convective circulation. Convective circulation refers to the vertical movement of air caused by temperature differences. It involves the rising of warm air and the sinking of cool air. This process is driven by density variations due to temperature disparities. Cool air sinking. In convective circulation, cool air plays a crucial role in initiating the process. As the cool air sinks, it displaces the warmer air, forcing it upward. This sinking motion occurs because the denser, cooler air is subject to gravitational pull and naturally moves downward. Warm air rising. As the cool air sinks, it creates a region of lower pressure near the surface. Simultaneously, the warm air above, being less dense, experiences less pressure and begins to rise. This rising motion is known as an updraft or thermal updraft. Convection and thermals. Thermals are localized areas of convective circulation where warm air rises in a column. They are often associated with the development of cumulus clouds and can provide lift for gliders and soaring birds. The development of convective circulation, including the formation of thermals, relies on the sinking of cooler air to displace and force the warmer air upward. This process is driven by differences in air density caused by temperature variations. The sinking of cool air sets the stage for the rising of warm air, creating vertical air currents and facilitating convective circulation. Understanding these dynamics is crucial for pilots, meteorologists, and aviation enthusiasts as they assess weather patterns, predict turbulence, and make informed decisions regarding flight routes and safety. 6231. Which statement is true regarding the effect of fronts on soaring conditions? A. A slow-moving front provides the strongest lift. B. Excellent soaring conditions usually exist in the cold air ahead of a warm front. C. Frequently the air behind a cold front provides excellent soaring for several days. The correct answer is C. Cold front. A cold front occurs when a mass of cold air replaces a region of warmer air. As the cold front moves forward, it displaces the warm air ahead of it, leading to changes in atmospheric conditions. Soaring conditions. Soaring conditions refer to the presence of updrafts or rising currents of air that provide lift for gliders and other soaring aircraft. These updrafts allow pilots to stay aloft and potentially gain altitude without the need for engine power. Air behind a cold front. Behind a cold front, the air mass is typically characterized by cooler temperatures and often drier air. These postfrontal conditions can create favorable circumstances for soaring. Atmospheric stability. The passage of a cold front can destabilize the atmosphere. The contrast between the cold air behind the front and the warm air ahead of it can lead to vertical motion in the atmosphere, promoting the formation of thermals and updrafts. Wind patterns. Behind a cold front, wind patterns often change, with winds shifting to a northerly or northwesterly direction. These postfrontal winds can interact with local topography, such as mountains or hills, creating additional lifting mechanisms for soaring. Persistence of soaring conditions. The air behind a cold front can provide excellent soaring conditions for several days. This is because the stable and cooler air mass tends to maintain the presence of thermals and favorable updrafts, supporting sustained soaring activities. It's important to note that the specific characteristics of soaring conditions and the duration of favorable conditions can vary depending on various factors, including the speed and intensity of the cold front, local weather patterns, and other atmospheric dynamics. However, the general trend is that the air behind a cold front often offers excellent soaring opportunities for an extended period. Pilots and soaring enthusiasts keenly monitor weather forecasts and analyze the movement of fronts to plan their flights and take advantage of the best soaring conditions available. 6237. An important precaution when soaring in a dust devil is to A. Avoid the eye of the vortex because of extreme turbulence. B. Avoid steep turns on the upwind side to prevent being blown into the vortex. C. Avoid the clear area at the outside edge of the dust because of severe downdrafts. The correct answer is A. When soaring in a dust devil, it is essential to exercise caution and avoid the eye of the vortex because of the extreme turbulence it produces. Dust devils are thermally driven vertical air columns that can form in warm, dry conditions, often in arid regions. These swirling columns of air can create hazardous flying conditions for pilots. The eye of the vortex, located at the center of the dust devil, is characterized by intense turbulence caused by the rapid ascent of air. This turbulent zone can lead to sudden and unpredictable changes in wind direction and speed, making it challenging to maintain control of the aircraft. In extreme cases, the turbulence can be strong enough to induce loss of control or structural damage to the aircraft. By staying clear of the eye of the vortex, pilots can minimize the risks associated with the turbulent airflow. It is advisable to maintain a safe distance and maneuver around the perimeter of the dust devil, where the turbulence is relatively less severe. This approach allows pilots to continue soaring while avoiding the most dangerous part of the dust devil and ensuring a safer flying experience. 6236. Which thermal indices would predict the best probability of good soaring conditions? A +5, B -5, C -10. The correct answer is C. The thermal index is a measure of atmospheric stability that helps glider pilots assess the likelihood of finding strong thermals, which are crucial for successful soaring flights. A negative thermal index indicates an unstable atmosphere, which is generally more favorable for soaring. When the thermal index is -10, It signifies highly unstable atmospheric conditions. This means that there is a significant potential for the formation of strong thermals. In such conditions, the air near the surface becomes much warmer than the surrounding air due to solar heating or other sources of heat. This temperature difference creates buoyant updrafts, allowing gliders to ride these rising columns of warm air and gain altitude. A thermal index of -10 suggests that the atmosphere is highly conducive to the development of powerful thermals, providing excellent lift for glider pilots. With the presence of strong thermals, gliders can stay aloft for extended periods, cover greater distances, and potentially engage in cross-country soaring flights. In contrast, positive thermal indices, such as +5, indicate more stable atmospheric conditions. In stable conditions, the likelihood of encountering strong thermals is reduced, making it more challenging for gliders to gain altitude and sustain flight. Therefore, a thermal index of -10 offers the best probability of encountering favorable soaring conditions with abundant strong thermals. Pilots can take advantage of these optimal conditions to enjoy longer and more successful soaring flights.